The first rule is known as the chain rule. I call it anarchy myself, but I'll explain that in a sec. Formally, that's the rule. U is some function of x. So that's what it is. Now, personally, I don't remember it that way. Personally, I remember it this way. See? Anarchy. Bring down the power. All right? So you bring down the power, then you lower the power. Right? So imagine you're overthrowing the government or whatever it is. So you bring down the power, and then what do? You throw them on the ground. You really want to trample these people. So you bring down the power, then you lower the power. And then, well, diff the inside is like putting the boot in, because you want to get them in the insides. So, all right, bring down the power, lower the power, diff the inside. There you go. That's the chain rule. Now, it means we can differentiate something like this without expanding out. Now, okay, it's not a hard thing to expand out, but because that was the example we did yesterday, just to show you, it does come up with the same answer. So, bring down the power, so the 2 now comes to the front. Lower the power, 2 becomes 1. Diff the inside. So whatever's inside the parentheses, we differentiate, and that's 2. And if I tidy that up, I get 4 lots of 2x plus 1, which is the same answer as yesterday. I mean, yesterday it wasn't factorised. We had 8x plus 4, but it's the same answer. But what that means is, if we've got a really high power, that's great, because I don't want to be expanding things out such as this, 3x minus 4 to the power of 7. I mean, I could do it, but it's going to take some time. So this way, I can bring down the power, 7, lower the power, 6, diff the inside. Well, the derivative of 3x minus 4 is 3. 7 3s are 21. And there's my answer. So a big time saver. X squared minus 10 all cubed, again. Bring down the power, 3 comes to the front. Lower the power, 2. Diff the inside. Well, inside the parentheses, x squared minus 10, differentiate that, I get 2x. Tidying that up, 3 times 2x, 6x, x squared minus 10 squared. Doesn't matter if there's a number out the front, just like we saw yesterday. When we bring that power down, we just multiply the 2 numbers together. So bring down the power, 5 6s are 30. Lower the power, it becomes 5. Diff the inside. Inside is 4 minus 2x. Differentiate that, we get negative 2. So we have negative 60. 4 minus 2x to the power of 5. Okay, each one of those, yes, we could expand out. Something like this, though, we can't. I mean, how do you expand out the square root of x squared minus 3? I put it in index form, x squared minus 3 to the power of a half, but I can't expand that out. But I can use the chain rule to differentiate it, because I can bring down the power, a half, lower the power, half minus 1, negative half, diff the inside, differentiate x squared minus 3, you get 2x. Half times 2x is x. Now, there's a mere mortal answer. There's our super mathematician answer. X on the square root of x squared minus 3. This is another way of writing the chain rule that you sometimes see. Because a derivative is a rate. And rates, you remember, are like fractions. So you can build derivatives from other derivatives. So you could find dy dx by finding dy dt, finding dt dx, multiplying them together. You might be thinking, t? What's it got to do with t? There is this thing called parametric measurements, which we will look at, I think it's next term we've got planned to look at that. But it's where we write x and y in terms of a third variable. So in this case, t. If I want to find the derivative of something like this, what I'm saying is, well, I could find dx dt, that would be 4. I could find dy dt, that would be 4t, and then I can build dy dx out of those 2 derivatives. So dy dx would be dy dt times dt dx, 4t times, well, we've got dx to t, not the t dx. I'll just turn it upside down. It'll become a quarter. So 4t times a quarter, which gives us t. So that would be our derivative in terms of t. If I wanted the derivative in terms of x, what would the answer be? So we're saying y dx is equal to t. So what would the derivative be in terms of x? T is equal to x on 4. See? There it is right there. X is 4t. So if I wanted it in terms of x, I could do it, because I could then say, oh, well, t is x on 4. There's my derivative in terms of x. So that's a little bit of a sneak preview of something we'll look at in a bit more detail when we're looking at parametrics. Rule number 1.